Good morning. Welcome to electromagnetic waves class. Subject code 18AC 55. This is session 5. Electromagnetic waves 18AC 55 for 5th sem BE students. Electronics and Communication Engineering Department. Myself, Professor Randish SP, Associate Professor, Department of E&C, Government Engineering College, Carpet. Okay, in this session, we are going to discussing about a numerical problems and multiple choice question and answer related to model 1. Okay, before going to the problems and multiple choice questions, let us review or summarize the topic discussed in the module 1. Okay, in the module 1, we started the discussion from the vector analysis. What is the need of vector analysis? What is mean by vector approach? We learned. Then we learned scalar quantity and vector quantities, representation of the scalar and vector quantities. In vector algebra, we are seeing the addition, subtraction and multiplication of the vectors. Then we discussed coordinate system. Generally, the three coordinate systems are generally used, that is rectangular coordinate system, cylindrical coordinate system and spherical system, coordinate system we seen. Depending upon the shape of the object or a geometry of the object, the corresponding coordinate system is selected and you see the variable parameters of the or coordinate variables of the all these coordinate system. Then we learned vector calculus. Vector calculus is nothing but vector operation, that is vector integral and vector differentials. Okay, differential operations on vectors and integral operations on vector. These are the things we seen. There we seen line integrals, formation and calculation about the line integral, divergence. Okay, so many related things we discussed in the vector approach. That is part 1 of the model 1. Coming to the part 2 portion of the model 1, we have started the discussion from Coulomb's law, experimental law of Coulomb and its corresponding expression we see it there, that is F directly proportional to Q1 and Q2 divided by R square. This is the basic Coulomb's law equation. And this proportional is changed with a equivalence by the proportionality constant K. That is K is equal to 1 by 4 pi epsilon naught. There we substituted the propagation constant value. Then we defined the Coulomb's law as F is equal to Q1 Q2 divided by 4 pi epsilon naught R square. This is general formula of the Coulomb. Later we discussed Coulomb's law is expressed in the vector form. Okay, the Coulomb's law applies to a point charges or 2 point charges or more number of charges, and the corresponding direction is represented by the unit vector AR. Then you send the Coulomb's law in vector form as F is equal to Q1 into Q2 divided by 4 pi epsilon naught R square into the vector AR. Then we define the term electric field intensity as force per test charge. E is equal to F by Q, and in turn E is equal to Q divided by 4 pi epsilon naught R square into AR. This is the equation of the electric field intensity due to a single point charge. That is E is equal to F by Q, that is equal to Q divided by 4 pi epsilon naught R square into AR. This is the equation of the electric field intensity, and this is based on the Coulomb's law for the point charges we seen. Then you discussed continuous charge distribution, the total charge of the different distributions like line charge distribution, sheet charge, and volume charge. In line charge we seen Q is equal to line integral rho L into dl. This is the expression charge distribution equation. That is Q is equal to line integral rho L into dl for the line charge. Q is equal to surface integral rho s into ds for the sheet of charge. For the volume charge, Q is equal to volume integral rho v into dv. This is the equation is used. There we seen that line charge, for an line charge, the electric field intensity equation E is equal to rho L divided by 2 pi epsilon naught into rho into A rho. This is the equation obtained for the infinite line charge. Electric field intensity of the line charge is given by rho L divided by 2 pi epsilon naught rho into A rho cap. That is A rho cap is the unit vector. Then for a infinite sheet of charge, the value of the electric field intensity E is given by rho s divided by 2 epsilon naught into a unit vector. That is rho s divided by 2 epsilon naught into an. This is the equation for the sheet of charge. Similarly, for volume charge distribution, the value of the electric field intensity is E is equal to volume integral rho v into dv. This is the representation of the volume charge, that is rho v into dv, a small volume charge divided by 4 pi epsilon naught r square into ar is a unit vector. And we define the electric flux and electric flux density with the help of the some experiment conducting as using the two conducting sphere. One is a small sphere and one more is big sphere. In between they are placing a insulating material or a dielectric material. There exists a flux in the outer conducting sphere after placing a positive charge sphere inside. Okay, There we see that electric flux existence and electric flux density and relation between the electric flux density and electric field intensity we seen that. Okay, considering all these topics, let us discuss some few problems that are related to this topic what we discussed till now. Okay, first this is a problem number one is change the distributing uniformly over the plane z is equal to 10 centimeter with a density rho s is equal to 1 by 3 into pi nanocoulombs per meter. You have to find out the electric field intensity of the sheet of charge. See that the equation for the sheet of charge is nothing but rho s divided by 2 pi epsilon naught. 2 pi epsilon or 2 pi epsilon naught into rho s square. Substitute the value. Given value is 1 by 3 pi 1 by 3 into pi into 2 into value of the epsilon naught is epsilon is 10 to the power of minus 9 divided by 36 pi. Finally, you can get the value as 6 volts per meter. 6 volts per meter. Applying the conditions, if the boundary is greater than 10 centimeter, the value of E is equal to 6 AZ. Okay, electric field intensity existing in AZ direction, volt per meter. Suppose if the boundary is less than 10 centimeter, the value of E is equal to minus 6 AZ. It is in the opposite direction. That is minus 6 AZ volt per meter. Okay, let us take one more problem. A charge Q is situated at the origin. Obtain the electric field intensity at a point x, y, z. Okay, see this. The charge Q is situated at the origin. Situated at the origin. Origin means the value of x, y, z is generally a 0. Obtain the electric field intensity at the point P, x, y, z. In this, we are defining the equation for the electric field intensity is given by E is equal to Q divided by 4 pi epsilon r square into a unit vector, and the unit for the electric field intensity is volt per meter. Volt per meter. The value of r, vector r, is given by x into ax, y into ay. See here x coordinate into ax is the unit vector, r is equal to x into ax plus y into ay plus z into az, and the magnitude of r is given by square root of all the values, that is x square, y square and z square. The unit vector from the origin to point P is x, y, z is AR is equal to unit vector r divided by modulus of r or magnitude of r. You can place the value x into ax plus y into ay plus z into az divided by magnitude of r. Then you can substitute electric field intensity is equal to apply the value. See here the 4 pi epsilon is a constant. These three are constant. Only we are finding the value of capital R. Only you are finding the value of the capital R. The R value is nothing but R is equal to X into AX plus Y into AY plus Z into AZ. Okay, therefore you are getting this is value of R. This is value of R. R square is X square plus Y square Z square. Only you are taking the magnitude, not the unit vector direction, but it indicates all the direction. That is X, Y, Z direction. Therefore, you can see that final equation is E is equal to Q divided by 4 pi epsilon naught X square Y square Z square into AR. For the AR, you can write this equation one more time here also. That is electric field intensity is given by the formula this, and unit is watt per meter. Okay, let us take up a third problem. A point charge Q is equal to 30 nanocoulomb. He is located at the origin in Cartesian coordinates. Find the electric flux density T at the point 1, 3, minus 4 meters. Okay, let us observe this figure with respect to a given values. This is at the x is equal to 1. Here x is equal to, this is the x value 1. Then y is equal to 3. Now this is the y is equal to 3. And z is equal to minus 4. Now this is the point. This is the point. Represent, see here, this is the point. Represent 1, 3, minus 4. This is the position of the point P. From the origin, the diagonal distance is r, radius is r. We know that flux density, electric flux density is given by the formula for the single point charge Q divided by 4 pi r square into A. Substitute the value here. Q is equal to 30 nanocoulomb, that is 30 into 10 raised to minus 9 divided by 4 pi r, that is the 1 square plus 3 square plus 4 square, 1 plus 9 plus 16, add these things 26, ax 1 into ax, 3 into ay minus 4 into az. Here very important thing is whatever may be the value is given, you should write the basic formula or basic equation and try to substitute the values. Automatically you are going to get some idea and you can solve the problem very easily. Here remembering of the equation is important, then given value substitution and minimize it, and finally you can get the value here. See that Q 30 nanocoulomb, AR, this is the AR value, this is R, then simplifies it, and finally you can get the value D is equal to 91.8 picocoulombs per meter square. Let's take up one more problem. Find electric field intensity at a point 0, 3, 4 meters in Cartesian coordinates due to a point charge given is Q is equal to 0.5 microcoulombs at the origin. Let us find out the value of R. Here 0 is given, 3 is given, 4 is given. That is x is equal to 0, y is equal to 3 and z is equal to 4. X value is 0, only y and z values is existing. That is 3 into ay plus 4 into az. Now the value of r is equal to 5. The value of ar is equal to r divided by magnitude of r. Here r is equal to 5, we return that is magnitude, that is 5 is nothing but 3 square is 9, 4 square is 16. 9 plus 16 is equal to 25. Root 25 is equal to 5. See this AR value 0.6 AY and 0.8 AZ. Substitute in the electric field intensity equation, that is Q divided by 4 pi epsilon naught R square. Here Q is given as 0.5 micro, that is 10 raised to minus 6 divided by 4 pi epsilon naught. These are constant, only value of R is 5 square into the unit vector value 0.6 AY plus 8 AZ. Okay, this instead this give the equation. If you consider only a magnitude, that E is equal to, that is electric field intensity is 180 volt per meter in the direction AR. This is the value. Okay, let us take a next problem. Find E at the origin due to a point charge of 64.4 nanocoulomb located at -432 in Cartesian coordinates. Same similar values, that is only Q is changed and the value P is changed. See that, same that basic formula E, and find out the value of R, that is root 29, that is 4 square 16, 3 square 9, 16 plus 9 25 plus 2 square 29, root 29. Then value of R is 4ax minus 3ay and minus 2az. See here minus 4 is there. Okay, change the sign of the all the coordinate. This is plus, this is minus, and this is minus. See here 4ax minus 3ay minus 2ax. Substitute the value 64 nanocoulomb divided by 4 pi epsilon naught value, and R value is root 29, that R square is nothing but 29. Then unit vector value this one, and simply you can get the value like this. Then one more problem. This taken from line charge. Okay, that is a uniform line charge extend with rho L is 20 nanocoulomb per meter, lies along the z-axis. Find field intensity at a point 6.8, 3 meters. Line charge equation, rho L divided by 2 pi epsilon naught R into AR. Okay, this is a line charge. Line is a form of a cylinder. That is why the coordinates are 6 square plus 8 square. That is x square plus y square. That is 6 square plus 8 square is equal to 10 meter. The field is constant with z. Thus, substitute the value. Rho value is 20 nanocoulomb divided by 2 pi epsilon naught is constant. The value of R is 10. Finally, you can get the field is equal to 36 AR. 36 AR. Okay. You will see that some few numerical problems we discussed. What you do is list out the all the formula, then definitions, and they take a question paper and list out the problems, and you have to decide for the given problem what is the related equation or a formula, then substitute it and simplify. Finally you can get the answer. Okay, lastly you can take up the a few multiple choice questions. Okay, take a multiple choice questions as here. Coulomb's law is only true for point charges whose sizes are very small. Okay, Q1 and Q2 are very small. We find the definition, we can see it. From this you can conclude answer is C, that is very small. Second question, as per Coulomb's law, the force of attraction or repulsion between a two point charges is directly proportional to the product of magnitude of the charges. Directly proportional to product of magnitude of charges and inversely proportional to square of the distance between them. The inverse is here directly proportional to magnitude of the charges and inversely proportional to square of the distance between them. Okay, first you should understand whether it may be directly proportional or indirectly proportional in the Coulomb's law. See here, the Coulomb's force between two point charges are 10 microcoulomb and 5 microcoulomb placed at a distance of 150 centimeter is. Okay, you can take up the Coulomb's law. F is equal to Q1 Q2 divided by 4 pi epsilon naught R square. Okay, 4 pi epsilon naught is a constant, and instead of R you can substitute the value 150 centimeter. Easy conversion is centimeter is converted into meters, that is 150 centimeter is nothing but 1.5 meters, that is 4 pi epsilon naught into 1.5, and here in upside 10 into 5 micro coulombs. Okay, substitute the values, you can get automatically 0.2 Newton. Next, the value of K in Coulomb's law depends upon medium between the two charges. Medium between the two charges. Next, if the medium between the two charges is air, then the value of the constant K in SI unit will be 9 into 10 to the power of 9 Newton meter square per centimeter square. See, next problem. Coulomb's law is the product of which quantity? Charge. Coulomb's law deals with point charges. That is why the answer is charge. Okay, Coulomb's law. In the introduction class I told that Coulomb's law gives the details of electrostatics or stationary electric field. That is where the answer is A. That is Coulomb's law employed in electrostatics. Next question. The Coulomb's law is an implication of which law? Okay, Coulomb's law is implication of the Gauss law. Here a charge 2 into 10 to the power of minus 7 coulombs is acted by a force 0.9 Newton. Determine the distance to the other charge of 4.5 into 10 to the power of minus 7 coulombs. Both the charges are in vacuum. Here F is given, Q1 and Q2 is given. What you want to find out? Determine the distance to the, okay, here F is given, Q1, Q2 given, 4 pi epsilon naught constant is, we know that. Okay, substituting the value, you can get the value of 0.09, and okay, you can do it this one. Then one more question. Electric field intensity is a non-vector quantity. The field lines always emerge from the positive charge. Field lines always emerging from point charge. The direction of free test charge will be the direction of the electric field intensity. The spacing between the field lines shows their strength. The spacing between the field lines shows their strength of the field. Then the region around a charge Q in which it exerts a force on a test charge is called as a electric field. The SI unit of a electric flux density is coulombs per meter square. This cross product can be used to calculate angle between the two vectors. Any vector in a arbitrary direction can be replaced by the two or three vectors, that is arbitrary vectors which have the original vectors as their resultant. Which of the following is a vector? Surface tension, moment of inertia, pressure. Okay, all these are scalar quantities. That is why none of the one is a vector. That is why none of the above. Which of the following is a scalar quantity? Acceleration, electric field intensity, displacement, these are the vector quantity only. Work is a scalar quantity. Excuse me. And last question, what is the vertical component of a force 5 Newton acting on a particular particle along a direction making an angle as 60 degree? The answer is 2.5 Newton. Okay, finally you can see the references I told in the starting class. Shall I remember those things? That is prescribed textbook is Engineering Electromagnetics by 8 and J.A. Buck. This is prescribed textbook. I referred all these materials, that is Sham Outline Series Electromagnetics, Joseph Administer, Tata Migraines, Problems and Solutions of Electromagnetics by Haight and J. Buck, then Electromagnetic Fields Theory and Problems by T.V.S. Arun Murthy and S.P. Basavaraju for VTU and one more solved question paper for the field theory. I taken the front page of the this reference textbooks, that is this is the prescribed textbook. Actually this is the 7th edition. For your syllabus 8th edition, that is Engineering Electromagnetics by W.H. and Buck. Okay, this is the Bible for the electromagnetics theory. From the reference of this textbook, so many authors they were written their own textbooks. Now electromagnetics by J.A. Administer Outline Series. Okay, here this gives the here they are mentioned complete coverage of the fundamental of the electromagnetics. Okay, and solved and unsolved problems here. Then problems and solutions in electromagnetics. Whatever the prescribed exercise problem that are solved here by W.H. Buck. Okay, this is one of the textbook I referred from S. Chandra publications, electromagnetic fields, and the theory and problems. Okay, in this textbook, the objectives of the chapters and outcomes of the chapters, along with the equations and explanations, are very good. This is one of the textbook, that is field theory by Basavaraju. As for the VTU scheme, this is written, and here problems are solved in detail. Okay, and the graphical representation of the equations, they are given, the values are given. That's also noted. This is a very a good textbook, and some brilliant solved papers about the field theory we seen. Okay, thank you very much. Thank you.